My name is Becky Larson. I'm a professor at the University of Wisconsin-Madison. I've been there for quite some time now. It feels like forever, 15 years. I'm going to talk to you a little bit about processing systems. I'm going to go through a bit of data, so much you can't keep up, and then you won't be able to ask any questions. No, but I'll talk a little bit, and then I'll talk a little bit about some systems that we've been measuring recently that are treating to clean water to discharge. So I'm going to try to spend the bulk of the time there, but I want to give you some other information that we've been learning along the way. And I do have to give a shout out to Tyler, who's right over there, and Horacio, because any other professors know we don't really do anything these days. I sit at my computer a lot, so no. Jackpot. All right, so today we have a lot of dairy in Wisconsin, so all of our data is based on dairy systems. I'm going to talk about processing. We usually implement this type of processing after collection before storage. Occasionally we see some different layout, but that's typically what you'll see. I'm going to talk a little bit about solid liquid separation systems, including some membrane treatment and some advanced processing systems. I just want to, in case anybody hasn't seen a solid liquid separator, very simple, right? The most simple one, you're going in, you're separating manure, getting solids and liquids. You can use all kinds of very interesting technology to separate different components, do different things. The kind of question sometimes I ask producers is, why do you want to do that, right? So you can do a lot of things. You can spend a lot of money if you really want to. I think I was at a farm once where they had spent this huge amount of millions of dollars on this dissolved air flotation system. And then in the end, they were just mixing all the streams back together, right? So eventually they took it out, right? So it just wasn't working for them in their management style. So there's a lot of data needed to make decisions. And I actually think producers don't have a lot of the information. And actually, as a researcher, I don't know all the information. So the more we can test these systems and kind of put the data together, and that can be tough because you don't necessarily get to run two systems on the same manure at any time, right? So we need a lot of data to make assessments, and we don't always get the money to do that. So there's a lot of different systems. I'll talk about, there's different components of these systems. So like a clean water treatment system, as I sometimes refer to it, or a processing system actually has a lot of components. In some of these, we have screw presses, centrifuges. Sometimes you'll see a roller press, incline screen. These are probably the most common systems you'll see in Wisconsin. I know other places we get a few rotating drums and a few other things mixed in there as well, depending upon your manure consistency. But you can pair all these systems together, right? But they all have very different price tags and very different performances. The system I'm going to talk a little about today actually has two separators. So it goes from a screw press to a centrifuge, and then goes to ultrafiltration and then reverse osmosis. And so I'm going to show you a little bit of that data today once we get there. One of the things I do want to talk about, though, is a little bit about efficiency. I think Kenzie and I were working on some things, and like all the different ways, there's so many methodologies for calculating efficiency. And one things I'll say is, like, as we're moving more and more to looking at different systems, we need to relate those efficiencies to different systems and different parameters. You know, we're going to need more detail as we go. And especially a lot of times previously, we related a lot of things to total solids. But, you know, as you find, as the more data you add, the efficiencies are very different for those different things. I really like a paper that's out there by Guyan, and they were looking at separation efficiency, and they really were trying to describe like a low and high separation efficiency system. And there were some reasons that they were explaining that if you didn't achieve that kind of high separation system, you really weren't achieving a lot of the end goals that you were trying to get to. Now, those goals can be different for everybody, but I think it's a good benchmark in understanding, like, when you start to look at different parameters, you might be low and high efficiency. That might help producers decide what's useful for them, but really understanding your end goals is really important. So a while ago, we sampled a whole bunch of farms over like 2 years and did a lot of different separation efficiencies, and we're looking at all these different parameters. And the interesting thing we found, I mean, maybe not surprisingly to many people, was that the nitrogen, really, you separate out some organic nitrogen into the solids, but you don't separate out the remainder. The variability, even in systems using very similar screw presses with similar sized screens, was very high. The variability from sampling point to sampling point was very high as well. So you see just tons of variability, as we all see that with manure all the time. The only thing I wanted to say about this is one of the really important things that I try to talk to producers about is the products have very different characteristics. So one of the things we were noticing is that you're into solids, you're so much organic in there. The mineralization rate is a bit different when you apply that to fields. So people need to understand some of those products need to be handled differently because they're not going to produce what you think is going to happen, and then it's going to affect your yields if you don't think about that. But one of the other things was like the nitrogen to phosphorus ratios, that the systems could really, like high separation efficiency systems could really skew that higher and higher and higher to having more nitrogen. So really thinking about some of those things. All right, I already told you that. So the system that I'm going to talk about today with the clean water, I should show you this again. So there's a digester there. It went through screw presses. There's a centrifuge, ultrafiltration units, and a reverse osmosis unit. And Jeff paid for all of the samples for this, so I'm going to show you a little bit of the data. But because he paid for it, we got to run a ton of different parameters. I only have a few of them today because I don't have enough time. But just in case you've never seen some of these, they're like tubular systems that you can see at farms. These are just a few pictures of the different ones that are out there that we have at a few farms in Wisconsin. You get a lot of different products. So here's just a picture of some of them. They all look kind of the same, no, but they're not. So we get separated solids. Usually they're combining a lot of those. I would say even if they have different separation systems, they're usually not using those products differently. We have a lot of farms that are still having trouble finding the markets for some of those. Some of the systems that went in, like this particular one that we were sampling, they have a mandate to move 65% of the phosphorus from the dairies outside of the watershed. So they're particularly interested in trying to maximize phosphorus removal, but they have a lot of trouble. So I would say I'm always sitting in my office trying to think of what to do with manure solids. I hope some of you are too, because we need some more ideas on how to increase the value of those to make that more usable. But then you get that ultrafiltration and reverse osmosis concentrate, and then you have the discharge quality water. And this takes permits, so that's challenging, right? You have to go through this whole permitting process. The first person who put one of these in Wisconsin, it was a total pain, and I don't think they loved it, as they ever do. I would say now, we just had the Manure Summit, the Midwest Manure Summit, and we were talking to producers, some of them who had these. They didn't think the regulations were so tough. The time to get them was the bigger problem. I think we hear that a lot. And the other issue was that they say some of the permit numbers vary. So like one of the hard ones for them to hit in the discharge water is the ammonia concentration. And so they have different levels, and the DNR has reasons for doing that, but I think a little more transparency and trying to help farms understand why those numbers are different and what might drive that difference in numbers based on where you're discharging, et cetera, can help them plan a little better. So they're not expecting that number and then they get a permit for this other number and then have to adjust to that. So this is a giant table. We always say don't do this, but what I want to show you, I tried to highlight the things here. What I found interesting is as you get to these higher levels of separation, sometimes I question, there are a lot of maintenance, there are a lot of work, they cost a lot of money, but some of the benefits I don't think they even realize of so some of these products have really high nitrogen content and almost all of it is available. And so I would use that product very differently. And I think you could, I have this dream of us modeling it, Horacios will be ready for that, of that I would like to see if we can model and use that and look in the field better at what that is, trying to look at what the benefit cost-wise of that. Because I think if you use this more effectively, you could really increase your nitrogen use efficiency and save a bit of money. They don't. A lot of the farms still are mixing it together and storing it together. Because it does take a lot of management, and they don't necessarily always get a lot of benefit from that. So one of the other things we're talking about as we're redoing our manure availability and other things is we're trying to integrate some new data to give more flexibility to those that want to increase their processing systems, but get more advantage in the regulations in terms of how that's useful. Not to give them an unfair advantage, but to allow some flexibility for products that are different than the original starting manure. There's tons of data here. We're working on publishing the paper, so you can always reach out to me later. I couldn't go through all of it. I did want to put a few constituents in here. One of the things we looked at was separation index, and then we also looked at the recovery. And the separation index, you're seeing, you start to get a lot of solids after I wanted to treat this, so Tyler did all this data for me, and I asked, I don't just want the screw press and the centrifuge. I'd like you to also combine the two systems together. I was kind of interested to see what happens when you start doing that. And so you start to see, of course, not a lot of nitrogen removal for those systems, but you can see obviously a little bit more in the centrifuge coming out of there. One of the interesting things to me was the variation is pretty high. But when you started combining them together, the variation in performance and that separation performance got a lot lower, right? So the system seemed to be able to improve as you put them in series. I think I've always suspected this. I also think you probably don't need to use a centrifuge. I think everyone I know who puts in a centrifuge hates it and thinks the labor and the cost is really annoying. I think you could probably get to decent numbers leading into these systems that require more consistency with maybe some, you might want to do two screw presses and then go to an inclined screen or something. I think you could achieve that for less money. The one thing though I'll say is like when you're going into these advanced treatment systems, they really need consistency. That's why this is important. So if you're going into an advanced treatment system, consistency is really important because it'll allow you to increase your uptime. I think if you ask Tyler or Brian, who are sampling two different systems, they're down all the time because challenges of operational. They're fixing those. I think they work through them over time, but I think the consistency it really helps them. Okay. Oh, good. I only have 2 minutes to go. No, I'm just kidding. Okay. So removal efficiency. So you can see all the pieces here. You start to see, obviously, you're getting a lot more of the nitrogen removed in the reverse osmosis. This all made, pretty logical sense to me, but I think it's important that you see which piece is doing a lot of the work, right? And you understand where some of that's coming from. Particular, for me, it's more talking to the producer so they understand, because some of them get excited about something and that's not really what they want or based on what they're trying to achieve. And then you can do the cumulative. I think this is an easier way to look at it. So you see as it moves through the process, that's what's being removed. I actually think the best way to look at this, and I really like that Tyler put these together, is as you go through there, you can to see what percentage of each parameter or each volume is coming out at each point. I said that really well, huh? So clean water, it's about 36% of the incoming manure volume that is discharged. I think they claimed really close to that. I think they said 37 or 38. So their data was pretty on that. So good that the producers knew what they were getting. Some producers, I think, are a little, before they see the numbers, they think everything will be clean water. Actually, the producers don't so much. Maybe it's the folks who want the producers to put it in and maybe want to incentivize it. They think they're going to get all clean water, but just remembering there's still some of those products to deal with in those other parts. Tyler also made a lot of these great things. So you can, once we get this out there, you can see, the percentages of each that come out in each of these different components. Nothing too surprising in any of these. Again, the hardest thing about the discharge quality water, I think, Tyler, they said they didn't ever have a whole lot of problems hitting, and all the data that we should hit their permit. But they were saying more ability to remove ammonia in that clean water would have been helpful. All right, I know I only have 1 minute left, but I want to say Horacio had done this cool modeling that we had this, and then we collected a bunch of data, and we applied the new data from like actual farms to get the differences in emissions, right? So we're like applying the data to factors within the life cycle assessment model so we can see the impact. And you'll see that that changes the total outcome. This data is already published, so you can take a look at it. But he had modeled this previously, so one of the operators gave us the data where you can see for the no processing compared to this clean water treatment system, you do get a lot of reduction in methane and N2O. He's working now on modeling this new data we have so that we can kind of implement a stronger data set to back up some of that numbers. And again, nitrogen, I think, is a very important story, and we're continuing to work on that. I know I'm out of time. I just want to say there is a cost slide. This is actually in a fact sheet that I have, so you can find it there. We have a fact sheet about this. They're very annoying to find because I never get around to making my own website. So if you go to the Learning Store and just type in Larson, these will come up. And there's one on treating manure to clean water. You can get some of this information. The more detailed information isn't quite published yet. So that's my time. If you have any questions, otherwise, go.